An ion is an atom, radical, or molecule that has gained or lost one or more electrons and has a negative or positive charge. For example, when a sodium atom loses an electron, it becomes a sodium ion. Sodium ions have a positive charge. Other atoms become ions by gaining an electron. For example, when a chlorine atom gains an electron, it becomes a chloride ion. Chloride ions have a negative charge.
If an atom loses an electron, it then has one more proton than electron, and it has a positive charge. But if an atom gains an electron, it then has a negative charge.
An ion is an electrically charged atom. If the ion has more protons than electrons, it is a positive ion or cation. If it has more electrons than protons, it will be a negative ion or anion. Ionization is any process that causes a gaseous atom to become electrically charged. A sodium atom is ionized when energy is added to remove an electron. The amount of energy required to do this is called the ionization energy. Ionization energies differ among atoms. This table shows the ionization energy required to remove the first electron from an atom. Once an electron is removed from a neutral gaseous atom, the atom becomes positive, and its remaining electrons are held more tightly to the positive nucleus. Additional ionizations to remove a second or third electron require increasingly more energy. A gaseous atom can also ionize by gaining electrons. Most atoms release energy in this process. This energy represents the atom's electron affinity. Electron affinity can be thought of as the tendency of an atom to accept electrons. Atoms with high electron affinities tend to form negative ions more easily than those with low electron affinities. Some elements acquire electrons to form negative ions. In the case of chlorine, the formation of a negative ion is favored because the resulting chlorine has a full octet. In general, the closer the atom is to acquiring a full octet, the more strongly it attracts electrons. Chlorine has 7 valence electrons, and its electron affinity is negative 361.7. By convention, the more negative the number, the more strongly the atom attracts the negative electrons. Phosphorus has 5 valence electrons and an electron affinity of only negative 74.6. The electron affinity of aluminum with 3 valence electrons is negative 44.1. Because of the way electrons form orbitals, there are some lapses in this pattern. Nevertheless, the general trend holds.
Atomic radii increase down a group, but decrease across a period. The radius is smaller for a cation than for the parent atom. The radius is larger for an anion than for the parent atom. Ionic radii increase down a group. Ionic radii decrease across a period for cations and for anions.
Valence electrons are the electrons outside the outermost complete energy level. In oxygen, the first energy level, which can hold 2 electrons, is complete. The second energy level can hold 8 electrons, but oxygen only has 6. All of these are valence electrons. In this sodium atom, the first and second energy levels are full. The third energy level is not full. Sodium has only a single valence electron. Noble gases such as neon rarely react because all of their energy levels are complete. They don't have any valence electrons to participate in a reaction. The number of valence electrons for S and P block elements can be determined from the periodic table. For example, all members of the alkaline earth metals have 2 valence electrons, and all members of the nitrogen group have 5 valence electrons.